Okay, hello, welcome everyone. My name is Jarek, and I'm going to present you like a dark side of Kotlin. I will explain myself later. So about me, quickly, 3 decades of coding. I actually started with Commodore 64, with BASIC, great language, with a go-to. Why that was bothering people, I don't know. It worked perfectly, never failed me. But then I switched to C, C++. It worked for me perfectly. Well, what was wrong with that? I don't know. But yeah, people. Then I switched to Java, and I actually spent like about 15 years writing professionally Java. But I don't know. Then I switched to Kotlin and Scala. I don't know what was wrong with Java. I will try to address a little bit that today. Yeah, but it worked for me pretty well. And you know, Kotlin also worked for me, and even Scala worked for me, and even TypeScript. Okay, but for some reason I like the languages. And I work for a company called Digital Asset. We do something with smart contracts. Actually, we do language. We create the language to write safely smart contracts. But that's not about it. This talk is actually mostly basing on my experiences from a previous company, basically Java shops, where I used and introduced Kotlin, even to banks. Okay. So before I even start with a Kotlin abstraction, here is the definition from Wikipedia. Who knows what that abstraction is and can explain me easier than that's on the picture? Yeah, it's actually when you add, like everyone uses the word abstraction. Yeah, you use the word abstraction. I'm abstracting. This is abstraction. What is this? So actually, it says here there are like verb and a noun. Verb is abstracting, so create the process that you observe things and you find out the common thing, and the result of this, the generalization, is the abstraction. For me, it helped when I looked at the origin of the word. It comes from the word abstraction, separation, and actually it has very similar root as the word subtraction. You take something away. And basically, it's exactly how I would like to look at abstraction. You take away details that you don't want to see right now. You just subtract them. And that is an abstraction. So taking away this and the result of that. The point is that why we even do this abstracting. It's a boring process, yes? Here, this picture shows people juggling. So the point is we are humans. So when we look at the code or whatever, like complex process, it's sometimes tough to find out what's going on. Like who has seen a method that is 1,000 lines long? Yeah, we've been there. It's easy to find out what's going on. Yeah, that's probably the place where you are trying to save yourself with abstractions. So for instance, this one, like I won't go into the details, like create memory buffer. Do you even think about creating memory buffer nowadays? Like probably use Java and don't care about it. Like read file into buffer like this, like tons of multiple steps, like hundreds of steps to do something simple that you could summarize as an abstraction. Send email to SMTP. But when you do like, I don't know, you do a document management system, you want to notify user that the document has changed. You probably don't want to put all these steps inside a method that is just changing something in the document. You will probably extract it. Yeah? Maybe, I don't know you. I haven't coded with all of you, but I will address it. So maybe use this one form of abstraction, which is called the tool for abstracting, extracting method. So that then you see from a bigger picture. That's exactly the point. Why we do abstractions, we don't, so we want, the details are still there, but we don't want to look at them because we will never, anyhow, do not comprehend it because it's too much for us. We want to see only what's on top and see into the details when needed. The point is, I was talking about extracting a method. So actually the first company I worked with in Java, that was almost 20 years ago. Actually, it was more than 20 years ago. Oh my God. I entered the company, I realized that those guys actually had methods which were thousands of lines long. And I started to write my style, basically small methods. You know what happened? We're arguing all the time because they were saying, like, this is crap. If I want to read your code, I have to jump all the time in IDE I am lost. So people were basically complaining, and I was so angry at them. You know, but those are the times around year 2000. Books like Clean Code do not exist. There are other books, and basically those guys are arguing with me. We are shouting all the time. And they are even saying, you see, you don't even put comments in your code. But sorry, at that time I was convinced, really, that was year 2000, that writing comments is a good thing, but I didn't know what to comment. But those guys had plenty of comments, like here ends if that starts in line 1117. Tons of comments. This was pretty well commented code. Sometimes not if someone entered some lines, but okay, it was really well commented. And you know, it was straightforward. And you know, there's other thing. Back then, it was actually, if you were writing code, writing names that are like self-explanatory wasn't the thing. Actually, you were cool if you wrote a method which name was like underscore ABC. Actually, those are methods that were actually on the production. And it was considered cool. And you know, if you have such methods in a code, maybe it's actually better to have it in a one long method than to jump. But okay. So basically the point is like abstraction is an investment. And you, on the two levels, first, you have to extract maybe these methods or use some different tool. And second, you have to understand how it works. So calling a method probably is not the thing. You all know how it works. But any new tool you introduce, you have to learn it. Like a language that has a different abstraction, you have to learn it, and I will show it. But the point is that some investments, yeah, it happens, fail. They just do not work. Like this picture, I love it. Who knows what's wrong with this picture? It's actually Java. Okay, I wish, this is something that most of you will never encounter, and that's great, because okay, yeah, okay, great, one thing, but that's not the point here. It's something worse. Okay, it's like, you know, there are multiple levels of multiple problems. What? What is URL? Java net URL. Yeah, exactly. So I put how this code fails, and like you can encounter, mostly people encounter it when they have a problem with performance, because we know hash map is something we put the keys and we magically extract something, and we don't care how a hash map works. Most of us know, we studied it, but you know, then you forget. It just works magically. And then we use this. We cache something like a content of the page, adult page, and we put into this hash map, and then we take it, a page for kids, and guess what happens? Actually, this works on my machine. I won't switch to ID, but I get the same content, not for kids. Why? Who knows? Yeah, this is where abstraction is leaking. We think it's magical, we don't bother about this detail, but actually URL in JavaNet has a very, very crazy contract. If you have a hash code, and actually what matters here is mostly the equals method, it checks DNS, gets IP, and if IP is the same, it says, oh, that's the same address. Perfect. Yeah, and for instance, that actually happens in real life, that different domains are under the same IP. Previously, like in the past, that was actually very popular. Nowadays, less, but you can have it. Like on my machine, actually, I entered DNS, so that those were on the same IP. And then you have a problem. Mostly, you actually don't have this mix. You encounter this because it talks to internet. So if you have hash map with URL keys, it will be really slow. And you wonder why. But okay, that was like a little bit abstract. And now to the point about Kotlin. And by the way, original idea for me, I love that everyone laughs when we bash things, when we say this is stupid, this is stupid. I tried to do that with Kotlin, but I failed miserably because I'm a Kotlin fanboy. I have to admit that, sorry. If you came here and want to see how bad Kotlin is, I tried, but I couldn't. Like, part of the reason is maybe because for a few years I don't work with Kotlin anymore. I worked in the past and I was bringing it company. Now I work mostly with Scala, so Kotlin nowadays even looks better than in the past. Okay, but my message at the end of the message, at the end of this talk is Kotlin is not just a better Java. It's something different. It's a new way to express yourself, and I will show you with some fails in Kotlin and with some examples where crazy syntax can actually help you. So one thing about Kotlin initially, Kotlin had it easy. Let's say like the author of Kotlin could gather experience of, I don't know, 15 years of Java and even Scala. What was wrong in those languages? What was bad? And if you have this experience, you can avoid initial mistakes. You can have regular syntax. This is one of the examples. You know var keyword in Java. Yeah, who knows var? Great, yeah. Who uses that? Okay, great. The point is that in Java, it only works inside the methods. So you can, but you can't have a var fields. You still, yeah? Can you have a var fields in Java? No, so you have a syntax that only works in one place, but why can't you have a var fields in Java? In Kotlin, actually, var is for everything, for fields, for local variables, for even for arguments of constructor. So basically, but constructor argument is something that is argument of constructor and instantly becomes a field. So kind of like record does. So in Java, we have something for records, we have something for fields, the other syntax, and something for local variables. 3 different beasts to express something that can be done with one syntax, basically. It means that actually Kotlin, even though probably you've heard it's a very expressive language, you can do a lot with not that many lines of code, it's actually when you look at the grammar, at rules, it's simpler than Java. And it solves a lot of these pains. So null safety, you've probably heard it, like Java is the great language that, to produce hundreds of null pointer exceptions on production in a second. Actually, Golang is better in that. It's even faster. But yeah, but Kotlin really solves the problem. Even to the point, I can tell you that if you use a Java library that heavily relies on returning null, getting null, it's still, for me, at least the experience, my experience and my team, that it's still better to use it from Kotlin and safer than from Java, actually. Okay, it solves this problem you probably forgot, auto-boxing, int versus integer. Technically, yeah, it's now Java is abstracting it quite well, but you sometimes have this funny null pointer exception when, for instance, you put a big integer and assign it to a small int, and suddenly you get a crazy null pointer exception or something else. So this is basically much better solved in Kotlin. And by the way, this one is, this talk is not about the syntax of Kotlin, all this area where it's great. I'd rather want to show the crazy part, but who has tried generics with Kotlin? And who had seen that they work somehow better than in Java? And who can explain why? Yeah, there's a very subtle, it's really tough, because I was surprised that that's the same generics, a little bit different syntax, but seems one-to-one, but actually this is a different, so basically the strategy, how we fight with variance. So this supper extends. In Kotlin, we do it in a type, so it's a declaration side. So we say that list is of something that extends t, or so out t or something, like it actually depends, not that in the place where we use it in Java. And it appeared that this is so much more natural and easier to use. Like basically, if you wonder why the same generics work so much better in Kotlin, this is the thing. By the way, this is the same for C# and .NET. So people sometimes say that in .NET they have reified generics, so they basically exist in reflection, and that's why it's so great. Actually, no. So I argue with that. You see that they are so much easier to use than in Java because also, as in Kotlin, they use declaration side variants. And that actually makes a difference. And small things like unit versus void, you know that. And you have generics and you use void, you see that it looks crazy because void is kind of a type, but not a type. In Kotlin, they have a unit, which is like type which only has one object. It's a full reference type. And it's now, let's say, again, we have this property, simple syntax, less exceptions, and actually we cover more. But now we get into the magic. So what's this beast? Who knows what does it mean? Function. Yeah, so this after colon is actually a type in Kotlin. Isn't it a little bit crazy? But you know, in Java you have the same, because you can, for instance, have a small int and then you put brackets, and now you have from type int, you created array of int. So basically you have a way to having existing type create another type, array. But basically that's it in Java. Or you use generics. But in Kotlin we have more of this, let's say, native ways of creating type. When we have two types or more, we can create a function type. That basically describes a function. Not a big deal. It's a lambda basically from int to string. And in Java, you would write it with a function from int to string. Yeah, this more or less shows the same. But there is one difference in this picture. Because in Java, who had this problem? I have a supplier of integer. I have a factory of integer. I have a producer of integer. I have a callback of integer. I have function 0, by the way. This is a real name of integer. You know what? All of them are the same. And it's funny if you need one of them, but actually your other framework accepts only another. Then you have to convert from one lambda to more or less the same lambda, but differently named. Sometimes you want it actually, but mostly not. It's a nuance, like it's a problem, small problem to solve, but okay. But now, how we define lambdas in Kotlin? There is one way, like let's say the most natural, but you know, what's on the right side of the equals, it's basically how you write function in Kotlin. And funny thing, in Kotlin, multiple things are expressions. I will refer to that later. So, and definition of function, if expression itself, it basically returns the lambda. So you can define function and assign it to lambda f2. And finally, I have a function, I call it wrap, that's let's say the most natural way of writing function in Kotlin, or a method, from int to string, return, and then I use a method reference and create a lambda. So I have three ways. And you know what it resembles? The language that probably most of you have touched. And you are really happy. JavaScript. You know, in one code base, I have three different ways, actually even more, to define a function, yeah? But okay, it's just a Kotlin. But you know, this is a small nuance. What's more, you can extend the function type. Great. Yeah, it's more or less the same as in Java, I would say, implements function. Then I can have this method, and you look at this. So I can call it x_invoke10. Great. What is this? Yeah, so basically, what's hidden here, there is a nasty concept from 90s. Who knows what is it? Operator overloading. So basically, we can, and this is actually a very crazy thing. We overload operator of calling function. So we just have object x, and we directly call something on it. So in Kotlin, it's used. If you have a list, you can directly refer to elements of this list just by using braces. Yeah? So it's sometimes usable. For functions, it's very actually natural for lambdas to call it this way. So cool. But you know, why Java doesn't have operator overloading? I remember because I was C++ programmer in 90s, and we learned then that we have this operator overloading. So we can introduce it everywhere. And I remember that there were like libraries to operate on file system. And you know, they didn't have things like create file, delete file or something. They were using like operator ++, I don't know, for creating a file. You could do everything. And you know, you were having this code with operator overloading because it was so cool. And it was obviously perfectly readable, great. So when Java was created, everyone knew that that's really not great thing. Maybe let's don't do that because there were like tons of problems. But by the way, I haven't seen it on my eyes, but I had met a colleague that was saying that in one of C++ project for one of the Polish banks, they were basically stopped the project for 2 months, and effectively the project was canceled because someone overloaded multiplication operator. Went for vacation and forgot about it. And you know, 90s, there are no tests, there is no CI. Even, you know, if you share code, quite often it's via FTP, not even CVS or SVN didn't exist back then. So, you know, it was even hard to find out when it happened that our now multiplication works in a different way. Yeah, so I completely understand why Java doesn't have it. But then, you know, I was working for banks. I was doing arithmetic operations with big decimal. Who did it in Java? Is it nice? Okay, pervert. But, but the point is it actually safe? So I can tell you there are I've seen multiple errors in a code calculating on big decimals in Java, mostly because it was, if you have this cluttered so much with methods, you don't see the point. And there are even fancy, by the way, for instance, big decimal has a fancy method called set precision. And people use it like, I set precision on this big decimal, but you know what happens? And everything, you know, you have setter, so it changes the object. You know what happens? Big decimal is always immutable. So it will return you new big decimal that has a new precision, but will not affect the one that is actually you're working on. That's one of the most common mistakes. And by the way, precision is very important when you work with money. So really crazy. So we don't have operator overloading in Java, which is mostly cool because people don't do crazy stuff, but sometimes really it actually causes more harm. Okay, but you know there is more. I love specifically this one. Like we have a method, wrap_all, which takes a list of, for instance, integers, and then a recipe how I want to change each of these integers into string, so that at the end I will have a string. For instance, this call below says that for each x, wrap it with stars and put it, yeah, by the way, you see string interpolation, so no concatenation needed here. Great, Java 70 will have that, surely. And, you know, easy. But you know, then there is this picture. Have you seen a slight difference? Who has noticed? I will be. Where is the difference? So you see how many arguments wrap_all has? Only one here, but it still works. You know, this is a crazy thing for Kotlin. Like every time you have a lambda as a last parameter of a method, you can put it outside the braces. Just because it's fun. Obviously, it does no harm. Yeah, so I will show you, for instance, where it is funny. Because, for instance, you might have an if statement. Like, I have a1 integer, and upon condition, I assign a1 1 or 2. And now a great thing about Kotlin, you can write it this way. I told you before that Kotlin, almost everything is an expression. So if is an expression. If condition 1 else 2, and I can directly assign it. It would work. Perfect. I love this syntax. One thing to learn, because in Java you have also if expression, but it's this ternary operator. Great, but it's something new to learn. So less to learn in Kotlin, actually, to achieve the same. But now, what if a1 is a lambda from supplier of int? I can write it this way. This would work. And now yeah, the same way, symmetric, regular language, I put it this way. Will it work? Yeah, there is a compiler error. That doesn't work. That doesn't compile. You know why? That actually makes sense because most of the people actually after the, so you know, this here I had, after if I had a value 1 or 2, and I put a value of lambda 1 or 2, but actually it's producer, so it's lambda. Here it doesn't work because, yeah, they had to make exception because most of the time people after if write the block statements with block of statements, sorry. So if that was directly a lambda, there would be like ambiguity. What the author wanted. Here I know what I wanted, but normally it will be tough. So they decided to make an exception, like hard-coded exception in a compiler. Yeah, this is always a block of code. It's not a lambda. If you want to make a lambda, you have a workaround, put an arrow. Normally you never need to do that, but here you actually need to do that. Like arrow from nothing, from a real void, actually, it's nothing there, to 1, and that fixes the problem. Great. Okay, I'm fine with that. Yeah, if you go far with some features, you have to sometimes put some exceptions. Great. But now, let's look at this code. So I have some method, print with love, which prints, again, use string interpolation to put this string with a heart before. So, and now I want to use it. I have a method greetConference that takes lambda, then calls with lambda with GeeCON. That should be obvious what I want to achieve. Like with this one, print with love, I want to have love GeeCON. And here, like I told you can avoid braces, yeah? This is so cool, less braces, better. This is very Kotlin specific. It, who knows what it is? Yeah, because. Yeah, it's implicit. By the way, this is the same. This is for lambda. It in Kotlin is as a this for method. Yeah, for in class. Yeah, it's basically this thing you are operating it. If there is only one argument, that's actually cool. And then I have it. I use the method reference this way or with these braces. And you know, I call it and I have only 4 times love GeeCON. You know, it's not enough love for GeeCON. Where is this love gone, yeah? My heart is broken. Who knows? What? Yes, 9th line. And yeah, so great job. By the way, this is exact place when I've seen people really saying, oh my God, compiler doesn't work anymore for me. Why nothing is printed? Why nothing works? You know, this was easy example. Think when this is like saved to database and you wonder why nothing is saved. You know, let's say this is as it is. When you work with Kotlin, sooner or later you have this baptism. You encounter this twice, after that you are careful. But my opinion is that if you have it syntax, the method references are kind of redundant. They only bring more confusion. That's later you learn, but because, by the way, sometimes you actually want it. You want to learn return lambda that returns other lambda. It happens if you do functional programming. So it's not always that braces with method references are wrong. Here are just wrong, and the compiler will. By the way, IntelliJ actually shows here an error for some time. That's probably wrong, but yeah, who looks at the errors? Oh, warnings. Okay, sorry, not error warning. But okay, the point is this is in Polish. Why we even do that? Who will even need that? And I will now show you who. Why these crazy things in Kotlin? This is how we write JSON, yeah? Obviously. Who was writing JSON this way? Yeah, manual, like, what's wrong with that, yeah? It's obviously visible what JSON is created, how the result looks like, yeah, at the end. It's easy. I instantly see that. Now, I was doing that, and not once I was assigning property on a wrong level. Yeah, that happens, because in this picture, especially when it is more complex, it's really easy to assign something to the wrong place. You don't really see the big picture. And you know, what if I told you that you could write like this? This is a Kotlin. There's a trick, but yeah, it really compiles. I can prove that, but yeah. Honestly, I would tell you that I'd rather see it this way. You know, it's like colon is a very special sign in Kotlin. Maybe it's better to don't use the special sign like operator, but use 2 dots. Come on, it's the same thing. Yeah, it's just, you know, horizontally. No, that's, you know, it's if you pivot your monitor, it's okay. It's like you have to be flexible, or you just put your head to the back, and it's really done. And you know, it's actually Kotlin has some limitation. You have this square brackets. Actually, something should be in front, and so let's say I call it R. So still, this is so much more, let's say, convincing that it's JSON, and you know actually what will be printed than the original code here. Yeah, you can see it, yeah? I can work with such code, yeah? The point is like how to achieve that. Exactly, we use, for instance, operator overloading. We use this possibility that all these curly braces are actually lambdas that are called after the previous lambda as a second parameter. So otherwise, we would have to put the normal braces. So all of these crazy things I showed, actually, and even more, enabled me to do that. And for instance, here I have this R operator overloading, and then I have a special get method. Actually, you see here, it only would work for 3 elements. If I wanted to 4, I have to. But you know, if you write a library, you see multiple libraries. This is actually how people write them. This, you know, you do it once and it's solved. You have a syntax for JSON. But how to achieve that? It's actually a trick. If you do that on production, it will work, but the people will kill you very quickly. Because what if I told you that actually this is not a colon, but there exists a language which has a letter. This is very important, a letter that actually looks like a colon. It's in Unicode, so it's a valid infix operator. It's a valid method name. Cool. By the way, Java can do the same. Yeah, it's Unicode letter, so yeah, it's valid. But that's not even crazy. You know, you see this square braces. In front of them is the other letter. There are languages that have letters that are not visible, which is cool because you can use it for that kind of tricks. This is really, okay, I tell you, I only showed, and by the way, this abuse you can do actually to some extent with Java. Not that funny, not to achieve the same effect, but those letters actually, as Unicode letters, can be used in Java. But what I wanted to show you, actually, you can shoot you can do crazy stuff, you can actually be killed by your coworkers, but at the end of the day, there is a reason why we have this all crazy things in Kotlin, to create really powerful DSLs. So we have a specific domain where we want to express ourselves better, more naturally to this domain, and then we create DSL, and it's not, and Kotlin is really sometimes scary, but it's really well fitted for that. And the point is that it's not that in each project we write in Kotlin, we create these crazy DSLs. Where we create them? Everywhere, yeah, no. When we have something that repeats quite often, a domain, subdomain, like for instance, here is CoTest. CoTest is a frame. Who has used CoTest? Yeah, so some people. So basically, you know JUnit, obviously. I assume you know JUnit. It's so fun to write the method test that user when called with, that's a method name, yeah? Called with null string throws exception. That's a cool name for method. I love this. Then you comment, well, it throw, I test, blah, blah, blah. But in Kotlin, you don't have to play with CoTest, actually, with this stupid naming of methods. You actually write a string, what I wanted to test here. And then with other DSL, I write my assertions. It's so much more beautiful, like should be something, actually, okay, depends on your taste, there are different ways, but now these tests are, let's say, way more readable. Actually, in one of the companies, we initially were not allowed to write Java, but because tests were already in some projects written with Spock, so Groovy, they allowed us to write tests with Kotlin, like this. And then everyone looked at this Kotlin code and realized this is actually a cool language. And that's how we slowly introduced Kotlin to the production, actually. But typically, that's by the way, answer what if you want to try Kotlin, but you don't want to commit yourself, like on the production, there will be still Java, but I want to try if it's really nice. But by the way, you know that in Java, everything you want, you can achieve with like few random annotations, which is always a great idea. But here, there's a Tor framework, where you define routing for basically service, to which path goes where. And now this is a normal Kotlin code. It actually compiles, you can debug it, you can put breakpoints there. It's not that magic framework scans your classes and finds out if there are like annotations. It just executes. You can put some of them during the test, etc. You can even call it in a loop. It all works. And that's how, that's where we use these DSLs. They are maybe crazy, but we only do it in a few places, yeah. And that's the point. And then we use actually that our language is really expressive. But there is more, polymorphism. Yeah. What kinds of where is polymorphism in Java? Who knows? Yeah. So yeah, basically. Sorry, what you said? How you called the first one? Okay, it's called direct. Okay, let's call it subtype polymorphism. And you have other polymorphisms, by the way. Generics are also kind of polymorphism. Because what is polymorphism? You have write code once, and it works for different types, various types. And it works, subtype polymorphism works well, you know it. But it has small problem. Let's talk about JSON serializable, because obviously no one created Jackson, no one created JSON, no one created libraries that work with reflection. Kotlin serialization doesn't exist. We have to write it by hand. And you want to say that person extends something, so it's JSONable. That would be a proper Java name. And then the class person knows how to serialize itself to JSON, to string here. Yeah? And then we can have a polymorphic method, serialize a list. As long as objects on the list T are serializable JSON, then we can actually serialize list inside of brackets. That works cool. That's where polymorphism is great. Yeah. What about from JSON? Yeah. Yeah, you can try. You can try JSON deserializable. Like from JSON that you need, if I have a person and I want to deserialize this person, this way I would have first need some person, I don't know, like empty person. Then I would call from JSON, I will have filled person, maybe a new object, or I fill this one. Actually, I've seen this design. I remember there was a famous actually framework which had person is DB object. So first I create it with a new, then I call a load, and then I have a person which is loaded, which is this was crazy. This was like, we are using it and we knew this is really wrong. It's like when you do something and you instantly know this is so wrong on many levels. So basically it's a problem, but you know, when the language fails us, what we do, use design patterns to patch it. So there is a solution for that. You can call it strategy. Maybe there is even a better name for that. But let's say we have something called JSON support. So we know how to make to JSON, which was never the problem, but actually what's important, how to do from JSON and create this T, which we are interested. And then we create object. By the way, this is just singleton, so a class that has one instance. And we know how to deserialize person from JSON. This is like utility class, basically as a singleton, actually. And now we can write this deserialized array in a polymorphic way. As long, so we first have a JSON, here should be a string, actually. And then we have support, so we have to pass additional parameter, a strategy, how we deserialize objects of this type. And it would work. But you know what, if we have person that inside has a company, I don't know, which has, I don't know, user, address, and all of that are objects which have this JSON support. You can do that. It will work, but it will be a little bit tedious if you write it down. So what if I tell you that this concept of having this support something for a class is actually known in other languages, and it's called a type class. So basically a class has some capabilities, has some, but not the object of this class, but the class itself. Think of it, okay, I will let it, but in Kotlin we use something called context receivers. And now we just say that whenever you call deserialize array with some JSON, well, basically this is string, in context there should be a way, the recipe, how we actually deserialize objects of this type. And then we basically, for instance, in May, we call with person JSON support, so this object that has recipe, and we call this. Why it makes actually sense? Why not pass it everywhere? Because if you have multiple of these supports, we basically do once this with, and then you have all the rest of the code basically not cluttered with this nuance, that there is a deserialization recipe. It's so much easier to read. You use this abstraction, I don't care, I know there is something away. I don't care because it only makes the picture more complex. You know, it's nice when you learn the concept, the context receiver, and you learn that there is something called type classes. What is type class at the end? I call it interfaces on steroids. Well, because normally when you think in Java, you know there is interface, and you can call polymorphically method on this interface. But imagine that now your interfaces actually work for static methods. So they can from nothing create objects of your type. And that's actually this. This is just called in other languages type classes. And actually, Kotlin can support it. If you take this code from Kotlin, I write something in Kotlin with type classes with this context receiver and translate it to Java, I will have maybe strategy. This will work. But you will lose this ability, like, let's think about it in a more generic way. Like, I don't care. This is just interface, but more powerful. Yeah, so it's like you can express something in Kotlin that in Java loses the point, basically. And by the way, this is a really fun fact, that if you write like this, like above, it's cool. If you write it like below, it's uncool. Its code becomes ugly and unreadable. It's magic. You know what's below. It's Scala. I don't really see the difference that much, but you know what I know about it. And last thing that I want to cover, which is actually, who has written reactive code with tons of flat maps? Is it nice? Oh, I see, like, facepalm, like, yeah, it's a flat map. It's flat. Okay. Yeah, so, yeah, it works. It's even like, when it works, it's fun, but changing something isn't. So here I wanted actually not to show like typical mono, reactor, or whatever. I wanted to show it in a little bit different context. So either, who knows what either is? Yeah, like, can you explain? Yeah, so basically, like optional, you know optional of something. But optional is it's a very root, actually. Optional is a very root type. Like, you ask, give me this user. I don't have your user. And now you ask, why don't you have my user? I don't have your user. What you gonna do? And You know, either is more nice. It tells you, I have your user, or if I don't, I tell you, because it doesn't exist in the database, or because you didn't have permission, or because the database is, MongoDB and we don't know what's going on. So you can explain it. Basically, every optional, that's actually a law, that after a while, every optional actually tends to become either. If you write in Java, you probably use checked exceptions, so it's not so common, but yeah, if you write in Scala or functional Kotlin, is actually the case. Like, slowly, optionals become, in evolution of the code, eiters. So now I have few methods, like find user in database by ID. Maybe the user doesn't exist, or it exists. If it exists, I can find user group that the user belongs to. Then I have this group, or I have error because user is not in any group. Then I have a group, and I can again ask who is an admin. And finally, I want to notify admin that, about something. Or I want to print that, there is no admin to notify because. I didn't actually write why, but I could actually extract this, the reason. But, we have this few flat maps. This code is not ugly. It's actually readable. But I didn't want you to present you the real code from production because, that's not that funny and we'll lose the point. But we have few flat maps here. And you can probably agree that if we had 5 flat maps on different levels, that would be a little bit ugly in maintenance, even finding which brace belongs where. And ends, actually, those comments that my colleagues were doing, like, this fits perfectly to this style. Like, here ends flat map from line 2015. Oh, okay, that's great. So that's a solution. I will have to try it. But, what if I tell you that I can write it this way? This is proper Kotlin. Actually, it now even uses the arrow KT library. And they don't recommend to do it this way anymore, but it still works. Did you notice something special here on this picture? Something crazy. Suspend. What is suspend? Yeah, coroutines. What are coroutines for? What are coroutines for? To do eithers? What we do with coroutines? Yeah, okay. I will find you a name for that. Asynchronous code, like call something asynchronously. But pretend we are still like we do sentences one by one, like linearly. So basically, this is asynchronous call. That's what was suspend created for. Work nicely with asynchronous calls. Where is asynchronous call here? Do you see it? Okay, I answer. There is nowhere. We just abused the concept of coroutines to achieve something else, to improve readability of this flat mapping. So mostly if you work with React or RxJava, this is actually about asynchronicity. And we use the same thing to actually improve our asynchronous code, and people are satisfied. But we can do it in different places where there is nothing about threads and jobs to be done, scheduled, etc. And it's even more funny because there is only one suspend keyword. And suspend is a very tricky keyword because it's like there's only one, and you mark the function is suspend something, and it has now some limitation. It can be only called from other suspend, and you can basically call any suspend from it. And the point is that now you can mix these eithers with real asynchronous code. What will happen? Will it work? Actually, I will tell you that mostly it will work if you are very careful designing this, let's say, coroutine builder, but it's really a crazy thing. So we abused the engine. And it's even more. This suspend is really funny because you have to learn how it works. We have this method, tell me number. It has a suspend. It returns, what type it returns? Who knows? What? Int. Yeah, deferred int. Okay. Now, what did I tell you that when I called this, and I print it, I get the string surprise. It's an int that contains a string surprise. Is it a surprise? It was a surprise for me. And if I checked the class, it was Java lang string. It's a very, very crazy int, which is a string. Like everyone that codes in JavaScript understands that immediately. I don't see the difference. Like a number is a string, but can be a string, not a problem. But it's like we are not used to that on the JVM. We have to learn that. But by the way, it looks, this is like a method I would love. Suspend coroutine unintercepted or return int but return a surprise. That's actually how you write the insides of this. And if you design these eiders, your own basically coroutine builders, you actually use this method. So I would say you have to be really evil to make this mistake, but you can. You know why? Because funny thing, on the JVM level, on the bytecode, every suspend function actually always returns an object. It's an object. And technically, if in this code, instead of x_any, I would write x_int, the Kotlin compiler will tell me, oh, it will tell me it's okay, it's int. If I will say it's string, it will tell me it doesn't compile because this method returns int. But after it's compiled, compiler has no power anymore. And because I use this trick, I return a string and it will work. Yeah, okay. So yeah, great job. Who needs type safety when you have a great language? Yeah. But okay, so we see that we can abuse the powers. What can we do when the power is abused? Who knows any Kotlin linter? Yeah, well, here at the end. What you know? Sonar. Okay, great one. Any other? Okay, so Sonar, basically, we want to prevent our colleagues from doing stupid things by using some linters. So we can limit what can be used. For instance, we allow these crazy things only in this piece of code, or we even totally don't allow. So if you have problems with those contracts, use linters. And I actually particularly love this linter called detect, which is really for me how the linter should work. It's very flexible, supports plugins. For instance, what it has, which I really love, a baseline. By the way, in Sonar, you can have more or less the same. That it says, okay, all that I have created so far was not according to the rules. Now I have 1,000 warnings and problems, but I say, this is my baseline. I just don't want to make more crimes anymore. And now you can live with that code, but anytime you bring something crazy, not allowed, it will tell you, oh, we accept it in the old code, but not in the new one, which is like very great thing. For instance, I created a plugin for this detect. It's called Kotlin. It's basically to write Haskell in Kotlin. I told you that Kotlin is very flexible. You can do pure functional programming in Kotlin. So for instance, for loops, while loops are not allowed, return keyword is not allowed, variables are not allowed. Who needs variable? If you don't know what your variable value is, like decide, yeah? Only use vals, etc. But just think that you can use these linters and they have really power and they can, on one hand, prevent you from writing stupid code, on the other hand, actually force you to write stupid code, like writing Haskell in Kotlin. Yeah, but we are getting to the end. So sometimes, as with these interfaces, type classes, we can't actually express ourselves in a great way, natural way, and we struggle. And when you struggle, what you can do? You can change the language, yeah? And the two ways, because you use the different language, you learn something, or your language is flexible and you can change it. Like Kotlin, you can change it to be completely different thing. It can be as a JavaScript or as a Haskell. And now is the point. How do you know that you struggle? How do you know that actually you have problem? Actually, typically you don't know. This is the blob paradox. It's an idea by Paul Graham, but I have to read it. Situation where a programmer sees the value of features in a language A that he uses, learned, and any language that doesn't have this feature is underpowered. It's not that. It doesn't make. But then he looks at the language B with more features. Who would even need that? This is we are all in this place. Yeah, it's like we learned this language. It's great. It's like my colleagues that were like writing this 1,000 lines or 2,000 lines methods. It was working fine for them. It's like with juggling. They learned how to juggle 100 oranges at once, and they mastered it. Now comes the guy and says, you know, do it only with 3 sticks, and they tried. Oh, sticks work differently than oranges. They can't juggle 3 sticks, even if there are, because they learned how to do that with 100 of oranges. And you know, from their perspective, I'm an asshole. They have something that worked, like really long methods. And now I try to force them to use some stupid thing only because I didn't learn to juggle 100 oranges. Yeah. So yeah, there are always 2 views. And I don't have a recipe where you should see what's good, what's wrong. It's like, yeah, it's our experience. But my point is like, languages like Kotlin, Scala, whatever, are not about writing less lines of code. This is easy. That doesn't bring. It's about do not making again the same mistakes, like null safety, having null safety. And, which is that was actually the content of this talk, expressing yourself easier, more naturally, because you have more powerful abstractions. And that's basically this. Kotlin, it's not about writing something in less line of code. It's the thing that once you learn some abstraction, you will write a code that if you translate it back to Java, and again to Kotlin, which is possible with IntelliJ, you will completely lose the point, because the original idea was looking nice in Kotlin, was readable, but you can only express it with this language. Okay, thank you very much. Other questions? Sorry? Oh, I haven't really checked the Slido. Okay, sorry, forgot about it. Okay. You have to help me. Okay. Okay. You know, I'm writing this on a. I have to move to wall. Sorry, I have 4. Okay, and room 6. Room 6 or 6? There's 6. GeeCON here. Okay. 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 Oh, room 6. Okay. Oh, now I can. Oh, these are actually great questions. Already see. So why bother with suspend when JDK 21 offers the virtual threads? Isn't better to achieve the same plain old Java without convoluting the language syntax? Yeah. So to some extent, actually, I agree that. But first, I actually hate a little bit suspend keyword, and I consider really virtual thread a better choice here. And by the way, they still what? Okay, and they, by the way, still work with actually Kotlin. But as I shown you, I used actually suspend to something completely different when multi-threading. Actually, I showed it for, abused it for something else. And I would say I wish the Kotlin actually had something else, but I don't want to get into that. That's basically monadic comprehensions. But I consider the suspend basically a wasted effort, especially with virtual threads, because that's let's say for me it's the most ugly solution to the complex problem. Yeah, but virtual threads is a better solution in my opinion. Okay. Okay. Yeah, so like but you can have that with virtual threads, yeah. You can't? You can use it. Yeah. Virtual threads on itself are just on blocking, right? You need to use structured concurrency, actually. Yeah, I think you have that. Okay, I haven't actually gone that far with a virtual thread in Java 21, mostly because I have something that I consider better, you know, blurb paradox. In Scala, which is basically IO monad, but okay, that's a different thing. And I wish Kotlin had this, but doesn't. Okay, on the topic of, let's go to the next question. I know on var simplicity, the difference is in C-like, C-like syntax or Pascal-like syntax. Definition is, yeah, that's exactly the point. So I completely understand why Java has this syntax, like first type, because back then that was a mainstream. And you know, as a mainstream, we can't make a big moves. If we introduce the syntax like we have right now with Java, Java probably would never become popular, because C++ programmers, as me, for instance, back then, I switched to Java to write better C++. But if I had to learn completely different syntax, probably I would never do that as millions of other programmers, and Java would never become popular. Yeah, that's the price you pay for being a mainstream solution. Sometimes you can't do big steps. Okay. And that's it. Thank you.